Hello, my name is Luke and I'm an instructor at 10x Developer. In this video, I will show how to set up a Monorepo structure for a distributed platform that consists of React frontend and Express.js backend, both written in TypeScript because TypeScript is 10x JavaScript. Although in this case, the language does not matter because I'm going to show how to run everything inside Docker containers, so this can be used to run software written in any other language. To be honest with you, I don't even have Node.js installed on my computer. Running everything in Docker makes it very much easier to set up a local development environment, because regardless of what technologies your project is built with, in order to run it on locally, all you need to have installed is Docker. For your convenience, the rest of this video is divided into 5 sections. In the description below, you will find the timestamp links, so you can jump directly into specific section if you're only interested in that exact topic. These 5 sections will be covering the following things. First, I want to start with explaining what exactly I mean when I say Monorepo. Second, I will show how to generate a React application using Create React App script. In the third section, I will configure Docker Compose to run this React application locally. I will be using Makefile to avoid typing long Docker commands with multiple arguments. Then, I will bootstrap a small Express.js HTTP service with some very simple REST endpoint to serve as a backend for the React app. Finally, I will write some React code using Fetch API to show how does it exactly look when the frontend calls the backend, so we all gonna see both components working together. So that is what you're going to see in this video. To watch more from 10x Developer, please subscribe to this channel and do not hesitate to smash the like button so that I can see if there is any interest and I can provide more content like this. Thank you. Recently, I have started a new full stack project called Tasks. It is a to-do list application that helps me to stay on top of my tasks. Before, I was using the bullet journal analog system created by Ryder Carroll, and I think it helped me to become 10 times more productive. But then I realized that I need a digital system or an app because I kept forgetting to take my paper notebook with me. And my phone, I always have it around. In 10x Developer videos, I will be using Tasks as a standard codebase to provide examples that illustrate the topic which is being discussed. Tasks project indeed consists of a progressive web app built with React and a backend Node.js service for synchronizing data across different devices. Now, we are going to replicate the same structure as if we were about to start Tasks project over again. You know, when I actually started Tasks, I said, okay, there's going to be just one repository on the GitHub to store all the code for the backend and for the frontend. And that is basically what is called a Monorepo. So what is a Monorepo anyway? Essentially it is when we have several packages but we store them all in one source control repository. Opposite approach, when we have packages stored in multiple repositories, is called Polyrepo. In Polyrepo, we will have each repository having only one package in its root directory. And if there are more packages, they all gonna have their own repositories. Even if they have dependencies on each other, they are still kept separately. I think it was Unix philosophy that created this culture, where it is believed that each tool must do one job and must do it well. But that results in having your code spread across so many different places. Although package managers are great in fetching foreign dependencies, they are so great that Hello World React application has like 1,000 dependent node modules. When each package is evolving, versioning may become complicated, and it is hard to drop backwards compatibility as you cannot tell easily if some code is never used from another package. Maybe this is why Monorepo is getting more and more popular. It looks more simple, all packages are in the same place, and it is easy to find references. You don't need to create versioning strategies because everything in the repository is up to date. Finally, when you clone a Monorepo, you don't have to look anywhere else. You have all the code that you need to build and run your project. It is important to understand that there are 2 different types of Monorepo. First type is a colossal Monorepo. You may have heard that some big companies like Google, Facebook, or Twitter use their gigantic monorepos to store all their code and digital assets in one place. I'm talking about massive amounts of storage, billions lines of code. They estimate that at Google the repository takes more than 80 terabytes. And their custom build pipelines and version control systems are designed to work at this scale. And yes, they are more complex than a gasworks factory. Those big tech companies have good reasons to use this setup. But for the rest of the industry, people like us, it would not be a practical solution. It could be overkill. So instead, I would like to talk about platform monorepo, which is currently becoming a new trend. So in platform monorepo, code that runs together is kept together. Not all the code that you have, but only what is relevant for a specific project. So it can be all your backend services with all the front-end clients, maybe their build pipelines, and some shared libraries. So it goes through all the layers of your full stack, but it does not cross the boundaries of that domain. If you have your entire stack in one place, it makes it easy to onboard new developers to a project, allows refactoring across services with more confidence, and avoids version incompatibilities. Now I want to show how to set up a new platform monorepo. So we can go ahead and start organizing our code inside one directory containing multiple different packages. In this case, it's gonna be just two simple applications, a React frontend and a Node.js backend, both placed in one repository. We will start with a React application, because in TYPESCRIPT project, users first see the web app. So we start with virtually empty directory. I will use create React app script to create an app, conveniently named app, because I feel creative today. And I want TypeScript. As I said before, I don't have npm. Look, even Node cannot be found. Luckily, I have Docker here. So how can I run create React app? Okay, let's do it again. So, create React app, using TypeScript template. And then wrap this command with a Docker container, in which process working directory is mounted on /temp, and the working directory is set to this mount point. And we will use the official node image to this container. Run it. It is fetching the node image. It will take a while for this command to finish. Looks like it finished downloading the Docker images, and it started to run the npx command in the container already. So what is it exactly doing? Let's say on my computer I have tasks monorepo here, and I'm inside of this directory. There is nothing, just this license file here at the moment. When I start the container has its own sandboxed file system. On this /temp path inside the container, the tasks directory from the host machine will be mounted. Which means the container, while running, will be accessing this monorepo directory from my host machine. The npx command will generate this app directory, and the container will exit. But the changes done in the mounted directory will remain. So this app folder is effectively created in our monorepo. Alright, let's see. Okay, it looks like the command is finished. And yes, I can see the app directory. Let's give it a closer look. In the text editor, I can see this app directory has React application structure. To run it, I will use Docker Compose, a tool that describes how Docker containers run together. We need to create a Docker Compose YAML file. So let me just touch this file to create it. It's funny how you touch something that does not exist, and by doing so, you create it. I wish I could touch money like that. The file is here. Open it. Let's make it big. So the version is 3.7. And then in the services section, let me introduce this app configuration. We'll be using node image. The generated app directory will be mounted as a volume. And the commands in Docker will be run in this working directory. Entry point is bash, means that the command is a bash script. This pipe opens a multi-line. CI equals true is required when this app runs in a container, and it is just a normal npm start, but if it fails to execute, the container will fall back to this. First has to echo about the situation, saying that the service is not started, but the container is up. And what the container is doing is tailing nothing, which is a command that blocks until the end of times. But say, in case the npm started successfully, then we need to expose this port so that you can access the server on the local host. And that's it. Now let me touch a Makefile. Okay, now open this touched file. In this new Makefile, I will define some repetitive commands. First is up app. It will run Docker Compose to start the app. So let's define this long Docker Compose command here. Also make sure you use tabs and not spaces in the Makefile. Then let me declare logs. It is a really common thing you want to do. And then the next is install app. This will simply run npm install on the application container. App into will get you into the shell of the application. And last thing is a little bit different. Unrootify command. Because files created by Docker container belong to the root user and they are not writable to your normal user. An unrootify task will take back the ownership of these files. And now in the black window, we run makeup app task. So we don't have to write the long sausage of the Docker Compose command. We define this task in a Makefile. Makeup app command will bring up the app. Makes sense. And the log shows that the application is up and running on localhost. Take a look. This is a hello world React application. In tasks stack, there is also a backend service. Let's introduce it to the same Monorepo here, right next to this React.js frontend. So I'm making a directory here. Let me call this service sync, just like in the tasks project. To create a Node.js application from scratch, we use npm init. Again, we need to wrap it with Docker container to run the command. And then we share the sync directory as a volume in the container. And the same directory we use as a work directory. And when we execute this command, it creates a basic package.json file inside the container volume. So it's actually available on a host file system. Yeah? Okay, open it. And there's going to be a script to start the Express.js app. On development, we will use nodemon so that it can rerun TS node on any changes on the project files. And index.ts will be an entry point to this application. But when I try to save the package.json, I'm getting this permission issue. And I want to show how you can use make_unrootify to solve this type of issue. And if it asks for your password, just type it in. And now you can save the package JSON without any problems. Remember, in Docker Compose, I have already defined the run configuration for the React app. So you can simply copy this boilerplate from the app section and just paste it below and replace the names of the application to sync. And then we're not going to need this environment variable. And the port name will be different for this backend service. Say 4000. Now in the Makefile, we can also copy over the tasks to work with this new service. So this is the task that brings the container up. This one is to run npm install. And finally, this one is to get into the shell of the container. We just replace app with sync. We need to replace the container name and the task name itself. Just do the same with into task. And now, just make it even more convenient, I would like to introduce a combined up task that executes up app and the new up sync, so that in the end of the day you can bring everything up with one short command. And also it is good to have combined install, which is the same thing. And then we run make up sync to bring up the sync container. Shell into that container. And here, let's add some libraries for this Node.js application, which is Express HTTP server and the Quartz middleware. To run the server in the development mode, you need some additional dependencies. Nodemon, TypeScript, and tsNode. Okay, so now when these are installed, you can close this window. You can see here in the package.json, the new dependencies have been added. And then open another black window, and you're going to need a source directory for the sync server. And this file will be the entry point to this service. So open this new file. And here in the top, let me add the imports of the libraries. Express and course. Then declare an HTTP app, which will use course middleware. Declare port variable, which is equal to 4000, so your application can listen on that port and execute this callback when it is ready to serve incoming requests. And here just log the fact that the server is up and running. And so that we can access it on localhost using this port. And then the Express application will actually handle GET requests on the root URL. So now we can restart the whole world to see if the combined make task works. Make up. It restarted both containers. Let's see the logs. And the lines in yellow are from the sync server. Looks like it started to serve some HTTP. We can open it, and it looks good. the React application will be calling this sync HTTP endpoint using fetch API. So if we look at the logs again, we can see that the React app is also saying that it is up. So when you open it, you can look closely. There is an instruction for you to edit this file. So open the app directory, and inside source is this app.tsx. Here is the line you could see on the web page. Make it big here. What if I display some response from the sync server here? Add this new DL here with DT as a title. And the DD will be a placeholder for the sync status, which will come from the sync server. So let's declare the sync status somewhere above, saying it's going to come back from the state hook. With default value is loading. Okay, useState is not imported in this file. Okay, save it. And this is what we got. Alright, but it is not actual response from server. So let's make it happen right here. Use effect hook. We'll execute this callback. Import the hook first. So we simply fetch from localhost 4000. And then from the response, we are going to get the text. And then with this text as a string, actually we need to take the setter for a sync status from the state hook. Then just execute the setter, passing fetch text to it. And here we go. If it updates it now, yep, clearly gets the status from the sync server, which says it's active. And it looks like both components work nicely together. And the whole setup is now done. If you had troubles following this tutorial or you've missed something, you can simply check out tag from tasks repository using this command to get all the code which is written during this tutorial video. So you can play with it yourself, and if you wish, you can use it as a starting point for your own project. And that is all what I wanted to share in this video, and thank you so much if you made until this point. I really appreciate you watching it. I'm kind of new to YouTube, therefore if you have any feedback, please leave comment. Perhaps you can even suggest better ways of doing this thing. And if you want to be notified when I create more content, please subscribe to this channel. And thanks again, see you later!